Hello, welcome to another problem session. So these days we are doing the problem from 2024 JEE, and this is Advanced Physics paper 2, and this is question number 4. Okay, this is an interesting question. I just did question 2 and 3. They were not very interesting. Question 1 was interesting, and question 4 is interesting. And this is also a little bit confusing in terms of geometry. So you have to be very careful how you approach it. Okay, so this must be a torsion problem, right? Because look at this. This thing is wire, and you can say this wire comes like this and goes that way, and can carry current this way or this way. And when you have a magnetic field, if there's a torque on it, it will rotate the loop. And right now there is no torque from gravity, right? But if the loop is rotated, the torque will be there will be torque from gravity as well, and there will be torque from B0. So these two torques will balance out at some angle, and that is what it's saying, that angle is theta. Okay, so how do we figure out what's the torque from these two sources will be? Okay, so we can actually do the following. For the gravity, you can say if this loop is kind of tilted this way a little bit, so this this loop is in that orientation, and this line is behind this screen for me at angle theta. And if the gravity is pointed at the center of mass, mg, and this is r, so you can see the lever arm will be simply r sine theta. So the torque from gravity will be magnitude wise mg r sine theta. How do you get the torque from B0? So that we're gonna try to do a not just do like IL cross B kind of force. One way to do is mu, magnetic moment of this loop, cross B. That you can get the torque on mu is this. And what is mu? Mu, the magnitude of mu is a current that's flowing in, which is a constant current I, and times pi, the area of the loop, pi r square. So depending on which the current is going, it can be the direction for this vector. Direction for this vector will be, you can use a right-hand rule to get the direction. But because there are only two forces, the torques will kind of cancel out. So all I have to figure out is how to get the direction of these two guys. So you can see that you have a cross product of B0 is, the loop is pointed this way, B0 is up, and mu will be perpendicular to that. So if this angle was theta, this angle will be pi over 2 minus theta, and so mu cross b going to be mu b sine theta. That's going to be the magnitude tau from the b, let's call it b, will be mu b cosine theta, and this is going to be I by r square b cosine theta, and they are going to be equal to each other. So mgr sine theta will equal to pi r square I, b is b0 here, b0 cosine theta. So now what do? This question is given tangent theta, so I just divide by mgr cosine theta both sides. Cosine theta cancel out here, these guys go away. One of the r goes away. Then tangent theta turns out to be pi r I b0 over mg. Okay, so this is choice A. Okay, yeah, so let's go back and see a couple of places I could have made a mistake. I could have made a mistake, so this would be not sine theta. If it was a cosine theta mistake, then I will probably end up with here. So that's what they're testing. Do you get the torque formula for gravity right? Another place I could have made is, instead of pi r square, I may have remembered it's like 2 pi r or something like that. Then I would have gotten this. So that's another place is checking. Do you remember the magnetic moment corresponding to loop of current is going to be current times the area of the loop? Okay. All right. I think that's it for now. I'll see you in another video. Bye.